Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome you to week 11 the physics lecture once again. Myself, Mr. Atiq, is here from the science department once again. We have week 11, chapter 20 regarding physics. Section 3, we have to cover the pages from 707 to 714 about AC circuits and transformers. Okay, come to the preview. We will have to study, we will have to cover all these things like the objectives regarding AC circuits and transformers, then the effective currents, then we have a sample problem there and the book. Okay, you will have to study that thing by yourself, like you'll have to practice on them. Okay, and then we will come to the main topic, which is the transformer one. Okay, look at the objectives. Distinguish between RMS values and maximum values of current and potential difference. Root mean square RMS. Then solve the problems involving RMS and maximum values of current and EMF for the AC circuits. Electromotive force, okay, about regarding the AC circuits, where you cannot write here like A. It must be capital. This is what AC circuits. Apply the transformer equation to solve the problem. Always step up and step down transformer. Well, this might be quite interesting topic to deal with. So okay, for this lecture, sorry to say, you have to study your own book as well. Understand regarding the practice. Okay, over the transformer, the step up transformer and step down transformers. Effective current. Look at the first topic. The root mean square. Root mean square. Look at the mathematical term. Root and then mean and then square. RMS current of a circuit is the value of alternating current. Like alternating current, like you look at the fluctuating current. This the sinusoidal current, you can say, or the fluctuating current. Okay, we call them alternating current. That gives the same heating effect that the corresponding value of direct current does. Understand? For this thing, we have a page 709. There is a problem regarding the effective current, root mean square. Okay, you need to study that thing, must. The effective current, the RMS current and RMS EMF in an AC circuit. AC again, this is AC. Okay, are important measure of the characteristic of an AC circuit. Resistance influences current in an AC circuit. Remember, whenever you are going to cover up any AC circuit or any AC devices, the resistance will be there, lazim. Okay, this is so called important and must, because according to the Ohm law, we have V is equal to IR square. V is equal to IR, V is equal to IR. Like, let me write for that thing for you guys as well. V is equal to IR. Look at here. I wrote it down here. V is equal to IR. Look at. So whenever the voltage, like the AC thing, will be there. Okay, we are going to discuss. There must be current and then resistance as well. This is for the AC. Remember. Okay. Let me finish this thing again. This is the Ohm law, V is equal to IR. Anyhow, come to the topic. Induced or applied EMF, then current. For the instantaneous values, delta V, like the change in the voltage. Okay, change in the values. Then we have a current as well, denoted by I. Maximum values, delta V max. Okay, for the applied EMF, and for the current I max current. Okay, now we have RMS values. Delta VRMS is equal to delta V divided by max. This is the voltage at maximum peak or peak level divided by under the root 2. Then IRMS, look at, we have current here, IRMS root mean square. Okay, the current RMS is equal to I max divided by under the root 2. So similar value just only for the voltage and for the look at for the voltage, induced and applied EMF, voltage, and here for the current as well. Understand? Transformers, the main topic. Look at the transformers. A transformer is a device that increases or decreases the EMF of alternating current. Remember what? Alternating current. Now this is quite interesting. Alternating current. Okay. In order to increase and decrease. For the increment phenomena, when a transformer increases any device efficiency or any device alternating current, we call them what? Step up transformers. And whenever it is reliable, like you can say like if you apply a transformer to decrease the alternating current EMF, we call them what? Step down transformers. Later on we will study it in some few slides as well. Okay, the relationship between the input and the output EMF is given by the transformer equation. We have a transformer equation. Look at Vs. This S denotes what? The step up. V is the voltage, Vp. So step down transformer, step up transformer, step down transformer. N, V is the voltage, S and P are for the step up and step down transformers respectively. N is equal to number of loops. This N indicates what? Number of loops. Okay. Transformer continue. The transformer equations assume that no power is lost between the primary and secondary coil. Understand? We have a primary and secondary coils here, by the way. Okay. Down coils for transformers. Okay. Transformers equations assumes that no power is lost between the primary and secondary coils. Okay. However, real transformers are not perfectly efficient. Real transformer are not probably the lost, or you can say like there is no device such, the car not predicted that 100% of efficiency of any mechanical device or like engine and this or there, but until now lost must be there. Whenever you are going to study the AC, alternating current, and the resistance, remember this term. Whenever the resistance and I across the voltage are present, V is equal to IR, so the current loss must be there. Remember what? The current loss must be there. Real transformers typically have efficiencies ranges from 90 to 99. What do you mean by like the less than 100? Why? The lost is there. Okay, as I told you. Okay, the ignition coil is a gasoline engine, is a transformer as well. Like here the example in our book as well. Just a simple ignition spark plug. Okay, a step up transformers and auto ignition system. Auto ignition system, what? We have motorbikes regarding the auto ignition system based on and large cars as well. But as far as the spark plug is concerned, so consider the bike. We have an automatic ignition system in certain bikes as well, like the running or the sports bikes. Okay. Battery, ignition switch, how to turn it on, ignite. Okay. Then step up transformer, in order to boost up the thing. Step up is what? Like to boost the AC or the DC current. Okay, like this, look at it's a mechanical thing. Understand? Volt battery storage, capacitors are here, but it stores the AC electricity here. Okay, so step up transformers, the job of the step up transformer is what? Like to ignite them in a more efficient way, to give them enhancement again. Now we have positive and negative terminal as usual, present in the battery. Then computer, like to diagnose any statistical LCD statistics, we use to the computer as well, like the LED, digitized LED, which can show you like the meter readings. Or then the correct angle sensors here for the negative terminal especially. Okay, for the lost and for the gain. And then we have a spark plug. Look at spark plug is connected to one of the end is connected to the negative. Understand? It's okay. Then the spark plug, look at it will come here as well, to the main system. Understand? The ignition system. So it is a kind of step up transformer phenomena here. Usually here in Saudi Arabia, what I observed is what, like, the mechanical energy being converted into electrical energy. Okay, so in the national grid system stations, we have a structure. I set them out for you guys. This is the power station we have, and then look at the power stations are coming to the step up transformers here. These are the power stations storage areas, and then look at the step up transformer. Step up what? They will increase the voltage here in the current. Understand here, step up transformers. The job is what, like to decrease and to increase. As we studied for a transformer, that look at transformer is a device that increases and decreases the alternating current. Yes, so look at it will increase here, step up, it will increase here. Okay, it will give to the higher 132 kV or higher. Okay, to the higher transmission lines here. Okay, we call them higher transmission lines. Look at, whenever you saw such kind of structures, it is what, it will be more than 132 kV. Remember, there is a difference, there is a distinct value here which is entitled for everything that you have to, before going to climb this structure. Understand, it is a kind of tower, so there is a specific limit where a human body can be attractable. Remember, 132 kV is not a joke. Understand, this is what's completely higher transmission lines, national grid system. Look at, now then from the higher transmission lines we have step down transformers. Step down, why? Because to use this thing for different purposes now. Okay, look at, for the home, for the light industry, and for the heavy industry. Now look at the difference now. For the homes, step down transformers, there is a small transformers, 230 volts only can be used there, like 220 to 240 is the range of 60 by 50 hertz frequency. Okay, having, look at, for the home we have 230 value only in volt, but for the light industry, like for the small semi industry, 11 kV, kilovolt. Look at kV, this is a bit higher than this one. This is just a domestic use. Okay, but for the industries, you need to use it for the in the range of kV. Okay, kilovolt. Now look at, for the heavy industry. Okay, for the heavy industry, any manufacturing industry, for the operation of cars, and you can say like pasteurizations industries, like maintenance industries, for equipments, appliances, manufacturing, all the range is what, they lies in the heavy industries of them. Okay, they are going to use what, 33 kilovolts. So this is a bit higher as well than these two. Look at light industry 11 suppose, and heavy industry 33 kV. And for the domestic, like for the small appliances inside our homes, like to luminize the lights and the that is just in watt. Okay, like watts only. We need 110 energy maximum, and 110 operation devices to operate, and for the heavy, like for the iron and this or that, and for the heater, you can say we are gonna use we need to have a voltage which ranges from 220 to 240. Okay, so it's all about the transformer. Remember, step down transformer and step up transformers. Okay, step up transformers that increases the alternating current. Okay, the EMF of the alternating current. And step down transformer that decreases. Remember, this is the phenomena. And as this is just a kind of interesting topic, you can say, I hope you're gonna cover it. Try to solve the sample problems here, and another thing is, like, try to practice different Google structures as well for the transformers. Okay, see you then next week, inshallah.